We are going to spend the next few days talking about polynomial division. For today, we are strictly going to stick to a polynomial divided by a monomial. A polynomial is an expression with many terms, and a monomial is an expression with a single term. How do we do this? Well, you're first going to rewrite your problem, and you're going to put every single term from your polynomial over the monomial. So your polynomial is your dividend, and then your monomial is your divisor. And then we're going to reduce our fractions, and that's going to be our answer. Here are a couple examples for you. So I'm going to take my polynomial, so that's this first one here, the one with many terms, and I'm going to rewrite it, putting every single one of these terms over this monomial, my divisor. So you're just going to basically set up a bunch of fractions. 24m to the fourth over 8m plus 8m to the fourth over 8m plus 8m cubed over 8m. And then from there, we're just going to reduce all of our fractions. So 24 divided by 8 will give me 3. And remember your properties of exponents. If you are dividing two things with the same base, you're going to subtract your exponents. So if I have 4 m's on top and 1 on bottom, this 1 will cancel off 1 from the top, and I'm left with m to the third. Moving over to the second fraction, my 8's will cancel. Again, subtracting your exponents. You are going to have m to the third, and I just realized I made a mistake when I copied this one down. This should have been a 5. So 5 minus 1, that'll give me 4 right here. And then moving over to the last fraction, the 8's are going to cancel. M to the third divided by m to the first. 3 minus 1 is 2, so we end up with m squared. And that is your final answer. So you're just reducing fractions. For our next example, again, we're going to take 12n to the fourth, and you're going to put that over the 4n squared. 5n to the third, you're going to put that over 4n squared. And lastly, your 5n squared over 4n squared. And now we have it all set up and ready to go. We're just going to reduce our fractions. So 12 divided by 4 will give me 3. N to the fourth divided by n squared will give me an n squared because I'm subtracting those exponents. Moving over to the second fraction, 5 divided by 4, well, that doesn't divide evenly, so I want you to just leave it as a fraction. We don't want to put decimals in these. If the fraction reduces, go ahead and reduce it. If it doesn't, then it just is what it is, 5 over 4. Looking at my n's now, n to the third divided by n squared, 3 minus 2 is 1. Since the 3 is on top, I have 3 on top. That means I'm going to have 1 n on top left over. Moving over to the last fraction, again, 5 over 4 doesn't reduce, so it's just going to be 5 over 4. And my n squareds, well, those are going to cancel off because anything over itself is just 1. And there's your final answer. One more example for you. 16x cubed, I'm going to put that over 4x cubed plus 2x squared over 4x cubed plus 2x over 4x cubed. So now I have it set up. I'm going to go through, reduce all the fractions. 16 divided by 4 is 4. The x cubes are exactly the same as each other, so those are going to just cancel right off. Moving over to the second fraction, 2 over 4. Well, that's just going to reduce to 1/2. And now looking here, 2 x's on top, 3 x's on bottom. So this is going to leave me with an x on the bottom. If I cancel off these 2 x's with 2 x's from the bottom, I'm left with 1 x on the bottom. Moving over to the last fraction, 2 over 4, again, is 1/2. X on the top, 3 x's on the bottom. That means I'm going to be left with 2 x's on the bottom. Okay, so anybody that needs a little clarification on that, I'm going to go ahead and just look at this last fraction here. What this really is 2 times x on top over 4 times x times x times x on the bottom. So we have 1x on top, 3 x's on the bottom. So if you think about that, 1x on the top will cancel off 1x from the bottom. So I have 2 x's left, but they're just going to be in my denominator. So basically, you can subtract your exponents, but wherever the bigger exponent was, that's where the leftover x's are going to be. All right. Let me know if you guys have questions. Have a great day.